The summer of 2018 in central and eastern Pennsylvania will certainly be remembered for its historic rainfall, even continuing into this past weekend, where State College saw 2 consecutive days of over 2 inches of rainfall, something that has only been done once before in our climate records. When looking at the entirety of meteorological summer, which lasts from June through August, State College shattered its old record of total precipitation over this time frame, and July was the wettest on record at many locations in the central and eastern parts of the state. But diving a little deeper into the numbers, I began to notice a trend that many of the top 10 wettest summers have occurred since the turn of the century. I sat down with Dr. Michael Mann, a distinguished professor of atmospheric science at Penn State and the director of the Earth System Science Center, to see if there was a correlation between increased rainfall and climate change.
So in isolation, it might seem odd to say that climate change played a role. Hey, we get, wet, summers now and then just because of the vagaries of weather, random chance. But when you step back and you look at the larger scale pattern of the atmosphere during July and August, there was something very interesting going on. It's a phenomenon that we've actually published on. It has to do with what's known as planetary wave resonance. Rossby waves, planetary waves.
These Rossby waves are giant meanders in high altitude winds in the mid-latitudes of the globe. Some Rossby waves are very influential in our weather as they create the high and low pressure areas at Earth's surface.
Under certain conditions, you can get highly amplified Rossby waves. So you get these widely meandering Rossby waves that gives you very large sort of regional weather anomalies.
Normally, Rossby waves move eastward around the globe along with weather systems. However, sometimes this movement slows down or even freezes.
The jet stream sort of stalls out. The entire system remains stationary. So once again, you have very unusual weather, and it's persistent. The same location is under a low pressure system day after day. That's why we were getting dumped on, all that rain. But at the same time, that stationary, highly amplified Rossby wave pattern was giving us a very strong high pressure system in the west associated with the drought and the heat that led to unprecedented wildfire in California. The Arctic, unprecedented heat and drought. Europe, unprecedented heat. Japan had one of the worst flooding episodes on record. All of those regional anomalies were associated with this very unusual large-scale pattern. Our own research published last year indicates that climate change is making this phenomenon more frequent, and it's doing that in part because of the amplified warming of the Arctic. And just sort of weather 101, the jet stream owes its location to the north-south variations in temperature, the temperature gradient, in what's known as the thermal wind equation. So the warmer it is at the equator relative to the pole, the colder it is at the pole relative to the equator, the sharper that gradient, the stronger those westerly winds aloft, the jet stream. Arctic amplification, the fact that global warming is warming the Arctic faster, means you're decreasing that gradient, you're slowing down the jet stream, and you're also making this phenomenon more likely. So let's forget about the jet stream for a moment. If we knew nothing about the jet stream, there's some simple arguments for why certain types of weather extremes are expected to become more common in a warming planet, on a warming planet. Heat waves. As you warm up the planet, you're going to get more frequent and intense heat waves because you're just sort of shifting the bell curve over. And the tail of the bell curve, where you get those extreme events, increases quite a bit. So you get more of those heat extremes as you warm the planet. At the same time, you warm up the atmosphere, it can hold more water vapor through the Clausius-Clapeyron equation, and so that means that when conditions are conducive to precipitation, to rainfall, you get more of it, potentially in shorter periods of time. But that same equation, Clausius-Clapeyron, tells you that you're going to evaporate moisture from soils more rapidly at higher temperatures, and so in many regions you get worse drought.
And if we have an eye on the future, it doesn't look so bright if we continue to release fossil fuels into the atmosphere.
If you look at the projections of what's likely to happen over the next century, substantial parts of the planet become unlivable for human beings. Basically, heat indices become too too high for human habitation over basically, the bulk of the tropics. So heat is a problem. That heat, of course, is melting the ice. That's leading to sea level rise, along with the expansion of the ocean as the seawater expands with warming. The real worry, of course, is that we start to trigger some of these irreversible collapses in the ice sheets. We are locking in climate changes for centuries based on the actions that we are engaging in today. The good news is that there is still time to avert the worst impacts of climate change, but we really have to act now.
Across the globe, extreme weather events such as droughts, floods, and wildfires continue to be impacted by climate change, making them more prolonged and more severe. Here in Pennsylvania, more summers with extreme weather, such as this past summer where we saw exceptionally high rainfall totals, might be more common in our future due to the impacts of climate change. For Whether or Not, I'm Jacob Morse.